Hi, welcome to my video on part 5 of Find the Values of Trig Expressions number 1. This is a unit on reciprocal ratios. So find the value of trig expressions number 1. Triangle ABC has angle C 90 degrees. The secant of A equals 5/4. So let's draw the triangle ABC. This is angle C is 90 degrees, so let's put that in. We got A and B and C, so A and B. I'm going to put A up here and B here. And we have that secant is 5/4, so SOHCAHTOA gives us the relationships between the sides of a triangle in terms of S stands for sine, is opposite over hypotenuse. Cos is A adjacent over hypotenuse. T is tan, opposite over adjacent. And we also have done the reciprocal ratios. So the sine, the reciprocal is cosecant, hypotenuse over opposite. Cos, the reciprocal is secant, SEC, hypotenuse over adjacent. And tan is cot, COT, is adjacent over opposite, reciprocals. So we have secant A, and secant is hypotenuse over adjacent. So that means in this triangle, the hypotenuse is 5, and the hypotenuse is opposite the right angle. Hypotenuse is the longest side. The adjacent side to angle A is 4. So this side is adjacent, this side is opposite. In relation to angle A, 4 is adjacent. Now, we need to work out all of these. We need to use the Pythagorean property. C is the hypotenuse, which is 5. A is 4. And B, we can call B BX or B, whatever you wish. And 5 squared, 4 squared is x squared. 25 minus 16 equals x squared. 9 equals x squared. The square root of 9 plus minus the square root of x squared. So x is equal to plus minus 3. Because we're dealing with a triangle, we can only use the 3 here. And so that allows us now, because I have all 3 sides of the triangle, to do the trig ratios. So find the value of each as a fraction. The sine is opposite over hypotenuse in terms of A. Sine is opposite, 3 over hypotenuse, 5. And this means a multiplication, so I can put a multiplication sign here, or I could put brackets, either or. And the cot is adjacent over opposite in terms of angle A. Adjacent is 4, opposite is 3, so it's 4 over 3. So I filled it in. Now I will multiply. And when we multiply fractions, the first thing I look for is to cancel. So the 3's cancel out because they're top and bottom. 1 and 1. So 1 times 4 is 4. 5 times 1 is 5. So the first one is worked out. Let's work out B. 12, bracket. Let's do the inside of the bracket. Remember, PEMDAS, PEMDDAS, or BEDMAS, BEDMAS, either or, whatever you want. What I like to use is either one of these two. Now we got to get the secant of B. Secant is hypotenuse over adjacent. So there's angle B. Hypotenuse is 5. Adjacent is 3. So that's a 5/3. The tan of angle A. Tan is opposite over adjacent. There's angle A. Opposite over adjacent, which is 3/4. Now that I have the ratios filled in, now we will manipulate. We have to do PEMDAS. We have to do the inside of this bracket first. So we need a common denominator. Common denominator for 3 and 4 is 12, so we multiply this one by 4 over 4. Multiply this fraction by 3 over 3. That gives us 20 over 12 plus 9 over 12. And we continue, do the inside the brackets. Both fractions have the same denominator of 12, so we add up, we get 20 plus 9 is 29. Now we're multiplying, so because we're multiplying, that's 12 over 1. I can cancel the 12s, and I get an answer of 29. C, I have cosecant A divided by the cot of B. So the cosecant of A. Cosecant is hypotenuse over opposite. In terms of angle A, hypotenuse over opposite. Hypotenuse is 5, opposite is 3. Now I'm going to do the cos of B. Cos is adjacent over hypotenuse. So there's angle B adjacent is 3 over 5. So because we're dividing fractions, I could write down 5 over 3 divided by 3 over 5. So that means when you divide fractions, you multiply by the reciprocal, which is 5 over 3. 5 5s are 25. 3 times 3 is 9. That's simplified. Now let's work out D. If you want, you may pause your video and work these out too. Don't forget, you can pause your video at any time and give you a chance to do it to see if you know what you're doing. 16. So I'm going to work out the cosecant of B squared. So that's the cosecant of B. I'm going to put the square root here. So the cosecant of B, cosecant is hypotenuse over opposite for angle B. Here's angle B, hypotenuse over opposite, so that's a 5 over 4. Subtract 8, and we do the cot of angle B. And the cot of B is adjacent over opposite. Angle B, right here, is adjacent over opposite. Adjacent is 3 over opposite is 4. So I have the trig ratios filled in with the values. Now we'll manipulate. Remember, we're doing PEMDAS or bed math, PEMDAS. So we have to do the inside the brackets, so that's nothing to do. So now we have to do the exponents or powers. So we have to square this one first. So 5 over 4 times 5 over 4 gives us 25 over 16. So we have the powers done. Now we have to multiply or divide from left to right. So I have to go from left to right, multiplying and dividing. So I'm going to multiply here, and there's no division, so I'm going to multiply this first, and then multiply this one. We're going to subtract last. 16 times this, 16 over 1, we cancel the 16 to get a 25. And 4 cancels into 8 twice, so that's negative 2 times 3 is negative 6. And multiplication divisions are gone. Now we add or subtract last, so that gives us 19. And simplify. And we have another one to do on this page. But notice here now, this triangle PQR, angle Q is 90. The cot of P is 4 over 3. Triangle ABC, we have AC perpendicular to BC. The secant of A is 13 over 5. So find as a fraction this expression. So we have two different triangles. Let's draw the two triangles. Put one of them right here and call it, it says Q is the right angle, so we should find that right angle, put that in the right spot. So P and R could go anywhere. I'm just selecting to put them in these two places. And it says the cot, just write it down here now, the cot of P is 4 over 3. But according to Sakatoa, we have sine cos, and tan. That's the SOHCAHTOA. Sine is cosecant, hypotenuse over opposite. Cos is secant, is hypotenuse over adjacent. And cot is the reciprocal of tan, is adjacent over opposite. Always keep this in mind. Always look for these expressions, because once I put it at the top of the page, then I don't have to worry about it. I see what I have done. So cot of cot is adjacent over opposite in terms of P. So adjacent over opposite. In terms of P, adjacent is 4, opposite is 3. And that means now we need, let's see, probably need the other side as this hypotenuse. So we have a c squared is a squared plus b squared. C is the hypotenuse, so let's call that opposite the right angle, so is an x. A is 4, b is 3. 4 squared, 16, 3 squared, 9, x squared equals 25. We do the square root, and the square root with a plus minus. Square root of x squared is x, plus minus 5. And we can't have a negative dealing with a triangle. We can only have positive length, so that's a 5. Okay, we have another triangle. And this triangle is, we got a right angle. So we got AC is perpendicular to BC. Notice C is repeated twice. So C, this is A. C is perpendicular to BC. Because C is repeated twice, C must be the right angle. AC is perpendicular to BC. And we have the secant of angle A is 13 over 5. Secant is hypotenuse over adjacent, so that's hypotenuse over adjacent. So in this triangle, the hypotenuse opposite the right angle is 13. Adjacent to angle A is 5. Now we have to work out the other side. We're going to need it. C squared, A squared, plus B squared. And the hypotenuse is 13. A is 5, and the other side we'll call X. Again, I could call it B. 13 squared is 169. 5 squared is 25. 169 minus 25 equals x squared. X squared is 144. Now we do the square root of each side, plus minus, square root. The square root of x squared is x, plus minus square root of 144 is a 12. So this side is 12, or negative, but we can't put the negative in it. We're dealing with a triangle. Now, I have the triangles done. Let's work out these ratios here. Let's see, here we go. I'm talking about angle P, and I'm talking about tan. Look at tan. Tan is opposite over adjacent for angle P. Angle P, opposite over adjacent, so that's a 3 over 4. Plus the cosecant of A. Cosecant is hypotenuse over opposite for angle A. Hypotenuse over opposite, so that's 13 over 12. And we have to do the secant of R. Secant is hypotenuse over adjacent for R. Hypotenuse over adjacent. Hypotenuse adjacent is 5 over 3. Just got to be careful picking them out. The cot of angle A, cot is adjacent over opposite for angle A. Angle A adjacent is 5 over opposite 12. Now we have all the fractions filled in. Let's do this two ways. I'm going to do this two ways. Let's go. The fundamental way is that you simplify the numerator and simplify the denominator and then divide. So we're going to simplify the numerator. Common denominator for the top is 12. So this one is multiplied by 3 over 3. That gives me 9 over 12. Add on 13 over 12. The common denominator for the bottom is also 12. I got to multiply this fraction by 4 over 4. That gives me 20 over 12 minus 5 over 12. So both denominators for numerator and denominator of these two, this fraction is 12. Now that we have all with the same denominator, I can, because these two fractions have a 12, I can add a 12 and I'll get 22 over 12. Because these two have the same denominator of 12, 20 subtract 5 is 15. And because we're dividing, we'll multiply by the reciprocal of 12 over 5. And 12's cancel because they're numerator and denominator, so I get a 22 over 5 as a fraction. That's one way to do it. There's also another way, if you wanted to, and I just rewrite this fraction back again. So that's what I call the fundamental way. The fundamental way is simplify the top to a fraction, simplify the bottom to a fraction, and then multiply by the reciprocal. And it works out. Another way is the shortcut is find the LCD for top and bottom. The LCD for the top is 12. The LCD for the bottom is 12. The LCD for both, and I'll put both here, the LCD for both numerator and denominator is 12. So what we're going to do now is multiply the top and the bottom by 12. So we're going to multiply every term by 12. So if you multiply the top by 12, multiply the bottom by 12, you're keeping the balance. And what I do is that I multiply all terms, every term by 12, keeps it balanced. Because I multiplied by the LCD, every denominator will cancel. 4 into 12 goes 3, and that gives me a 9. 12 divides into 12 once, gives me 13. 3 into 12 goes 4. 4 times 5 is 20. 12 cancels into 12 once, we get a 5. And we add, we get 22 over, and did I multiply wrong? No, I'm subtracting over 15. Now, what did I do wrong? 9, 13, 22. How come I got a 15 there? Oh. I can't find my mistake. I did it here. I got 15, but I got that's over 15. Now, it's funny, when you go to look for it, you can't find it. You got a 9, they cancel, you got a 13, that's right. I got a 20 and a 5. Oh, I see what I did. See what I did? I left off the, see, when I flipped those, instead of being 15, I put a 5 here, but it should be a 15. So the two of them now works out to be the same. Again, as I say, be careful. I make an error. If I make an error, just hopefully I'll correct it before I end the video or see my mistake. So that's two ways to do this problem. This is the quicker way, multiplying a top and bottom by the LCD. And that's done in the section on rational expressions when you're simplifying what you call complex numbers. This is a complex fraction or complex number in that the numerator and or the denominator has fractions in it. So it's more complex, more complicated. And that brings us to the end. And if you like my video, click on the like button, click on the subscribe button, the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.